Okay, so I lost track where I was, but let's just go ahead and start again. Find the real zeros of f of x equals x cubed minus x squared minus 2x. So we go, just for practice, let's figure out what quadrants this polynomial will start and end with. We said that 3 was odd, so automatically go to your foundation and think of a line going in the positive direction or the negative direction. And in this case, the coefficient is 1, so we're going to think of a line going in the positive direction, and that means it's going to be in quadrants 1 and 3. 1 and 3. So let's go ahead and start solving this. Find the real zeros. That means that y is equal to 0, right? Because that's true at the x-intercept. That y will always be 0. F of x is the fancy way of saying y. So let me go ahead and get out of here, and we can go ahead and solve for it. And it's called the x-intercept because the values that we get will cross the x-axis. And one more thing that I want to stress to you is that the highest exponent, at the moment, the highest exponent is 3. That number is the number of roots, the number of x-intercepts, the number of solutions, the number of zeros that you should get. So I should get 3 answers. I should get 3 answers. So the first thing I'm going to do is I'm going to set the whole thing equal to 0. So I now have x cubed, 0 equals x cubed minus x squared minus 2x. Now I need to start factoring. Well, this one is easy right now because what we're going to do is we're going to factor out what they have in common. Each one of those has at least one x that you can take out. So let's do that. I'm going to take out one x from each term. If I do that, I'm left with x squared minus x minus 2. Okay, so I'm left with this part right here, which I'm not concerned about at the moment. And then this part right here, which is a quadratic. And I have briefly taught you how to factor quadratics. There's so many ways. The trial and error way, the T-table or T-chart way that Ms. Hastings has taught you, the box method that you may have been introduced either through me or through Ms. Cannon, and also the last one that a lot of you all tend to avoid is the quadratic formula. But for this one, it's going to be pretty simple, so let's try trial and error. So I have 0 equals, don't forget my x, and I'm going to factor that quadratic into 2 sets of parentheses. And I have x squared, so I know that can only happen if I have x and x. There's only, I'm trying to get a multiple of 2, and there's only one multiple of 2, and that's 1 and 2. Now I'm trying to get a negative 1, a negative 1x. That only happens if I have a negative 2 and a plus 1. How do you know if you factored correctly? FOIL these two out, and you should get the step above. So now at this point, now your next step is to set each part equal to 0 and solve for x. So this first one is already good to go. We already have it. It's already set up for you. It's x equals 0. There we go. This part, I have x plus 1 is equal to 0. I move this positive 1 to the other side, and it becomes a negative, so I end up getting x equals negative 1. And then I have x minus 2 is equal to 0. I move this negative 2 to the other side, and it becomes a positive 2, so I get x equals 2. So these are my roots, my x-intercepts, my solutions. How many did I get? I got 3. That's exactly how many I told you I was going to get by looking at the highest exponent in the polynomial function. So I have negative 1, 2 right here. This is a 2, guys. Don't think it's a 1. This is a 2 right here. So I have a 2, a negative 1, and 0. So now let's graph that. Let's definitely graph that. Negative 1, 0, and 2. All right. So I'm going to get a X and Y axis. And it may be crooked, so I do apologize. We have a negative 1. So negative 1 is right here. 0 and 2. Again, it's called x-intercepts because it crosses the x-axis. Now, I believe we said it's going to be in quadrants 1 and 3. So I'm going to check mark this right here just to kind of remind me that I should start an N somewhere there. All right, so let's go ahead and sketch our function. So it's going to start here. It's going to go through the first x-intercept. Then it's going to come back up and go through the second one. Then it's going to come back down and go through the third one. And it's going to end right here. And I'm going to end them with arrowheads on both ends. Okay, so that's a rough sketch of what your function should look like. Let's kind of check to see in the PowerPoint. So let's just go over this PowerPoint again. We set it equal to 0. We factored out an x. We factored out the quadratic. Set each one equal to 0, and we got 0, 2, and negative 1. So we look at a sketch and plot the x-intercepts. 0, 2, and negative 1. And we said that the positive x cubed means it ends in quadrants 1 and 3. And there we go. That's our graph. All right, moving on to the next one. We have negative 2x to the fourth plus 2x squared. Find the real zeros. Negative 2x to the fourth plus 2x squared. Negative 2x to the fourth plus 2x squared. Alright, so here we go. I went ahead and set it equal to 0. Go ahead and get it out the way. I really don't like negatives, and I really don't like for my x's to have coefficients. If I can try to reduce, I'm going to reduce. So you know what? I see that I can divide everything by 2. That will probably be the best bet, and it will make my life easier. So we have now 0 divided by 2. That's still going to give me 0. Negative 2 divided by 2. You know what? Well then, let's go ahead and get rid of the negative as well. So let's go ahead and divide by a negative 2. That's going to make life definitely easier. So 0 divided by a negative 2 is still 0. Negative 2 divided by a negative 2 is positive, so I'm just left with x to the fourth. And a positive 2 divided by a negative 2 is going to be a negative, and I'm just left with x squared. Much better. Much better. That's what I have now. So now I can see that I can take out an x. Actually, I can take out more than one x. I can take out 2 x's. I'm going to take out an x squared. And I am left here with x squared minus 1. How do you know if you factored correctly? Multiply it or distribute this back in, and you should get the step above. In this case, we can factor this quadratic. It's something very special that I have taught you, and I have said to always remember because it comes back this semester, and that is, would anyone like to attempt it? It is a difference of squares, and what do we know a difference of squares is? The same thing, except for there is a plus and or a minus. So let's see, how can we get x squared? X and x. How can we get a 1? 1 and 1. There we go. So now, actually, let's go up. The highest exponent here, the highest exponent is 4. So I should be expecting 4 answers. Let's see. 4 answers. All right, so I'm going to go ahead and start off with this one. 0 equals x squared. I don't want x squared, I want x, so I'm going to have to root. And I get 0 equals x, because the square root of 0 is still 0. Okay, so that's my first one. This one, x plus 1 equals 0. Move this plus 1 to the other side, x equals negative 1. If this video finishes, I'm not going to start a new one. So just go ahead and if you have an extra time, either go back to the notes and get whatever you missed, or start working on your homework. Start working on your homework. So I get here, x equals negative 1. Here I have x minus 1 is equal to 0. And move this negative 1 over, and I get x is equal to positive 1. All right, I only see 3 answers, so where could my fourth one be? All right, well, I want you to be careful because it's really in here. Whenever I took the square root of 0, technically I'm supposed to get plus or minus 0. But what is a positive 0 and a negative 0? It's still 0. So it's going to be the same number. In this case, this is what we call a double root. A double root. All right, so now it's going to be time to graph it. So negative 1, 1, and 0. Negative 1, 1, and 0. And let's just take a look at what quadrants we're going to be in. The highest exponent is 4. Think even or odd. All right, it's even, so automatically go to your foundation. Parabola opening up, parabola opening down. Now, what is the coefficient? Coefficient is negative, so think parabola opening down. Which two quadrants? Quadrants 3 and 4. Quadrants 3 and 4. So let's go ahead and check mark them so I won't forget. That's what I like to do. And let's start. All right, so I'm going to say I'm going to start here. Go through this x-intercept. Come back down. But the funny thing about double roots is that they don't exactly go through it. They reflect. Double roots reflect off of it. Come back up, then back down, and go through this one because it's not a double root. And that is your graph. We started and ended in quadrants 3 and 4. You have to remember that about double roots, that they bounce off, they reflect. All right, so let's see.